I welcome you to my another video about tools. I will be hitting 20,000 subscribers on my main Czech channel, so I wanted to do something serious that I could also record in English to feed up my fans who don't understand Czech. So it happens that I have these products, these precious Hioki multimeters for review, and believe me, the review will be thorough. Now, how I got them? Hioki is Japanese brand for measuring equipment, and it's like almost 100 years old, maybe. They have been producing top quality products since then, and all of them are made in Japan. Quality-wise, they belong to the same segment as Fluke, M-Probe, Bryman, Gossen Metrawatt, and such. Being made in Japan, they still manage to keep their prices reasonable, being priced similarly to Bryman or Unity, for example. I generally like Japanese guys or their brands. It's Panasonic, Sanyo, Sony or Subaru. Japanese are quite much into their pride and morality, so they would rather go bankrupt than to produce something of bad quality. We have seen that, as today age is more about marketing and colors than quality. Now to the topic, how I managed to get my hands on them. It was at Ampere 2022, that is Czech fair for electronics and electricians, something like Make Fair, for example, if you know it. But Ampere has been here for a longer time, since 1993, I believe. I wasn't alive back then. Spending approximately 10 hours on feed there, I managed to take a look at many things. And one of them was Hioki that caught my eye. I thought for myself, what is Hioki doing here? As they are unknown to European market. So I proceeded to the stand. The stand was of Teste company, that is officially Hioki distributor for Czech Republic and for Slovakia. Yes, we used to be Czechoslovakia. If you happen to be of another country, which I suppose, since Slovaks understand Czech pretty well and they would watch my Czech video, then you can find your local distributor. You can also mention this video that you got there and Teste company responsible for landing these multimeters and such directly for review. It won't hurt. Now the Teste company, they sell Tektronix, Catelys and such, and also this Hioki. Knowing Hioki only from web pages and maybe something like brief reviews or something, I began examining them. Teste sales representative was quite friendly, unlike some other brand representatives, and we were talking a lot about them when I mentioned my Czech YouTube channel with also multimeter reviews. As his eyes became lit, I showed him my channel and then he offered me cooperation, as this is the exact thing they need to get people to know Hioki, because no one will ever be buying something of brand he has no clue it even exists, while the tools are being a little more on the expensive side. If you take it globally, you don't care about the brand with sub $20 meters, but you care about brands above that price range. So it happened that the sales representative offered to lend me some instruments for review, and I went through all the catalog and chose DT4256 and DT4261. I have them brought for free and I have to return them. Here is the proof. You obviously, of course, you can't read Czech, but it's like zápůjční list, that means lending list or something like this. So I have to return them. It's not biased. Hioki offers 3 years warranty for their instruments and 1 year warranty for clean precision. We will check that, of course. Talking about digital multimeters, Hioki has 4 series of DMMs. Let's open page 14. This is all in English and it's distributed by Teste company. We got here DT4220 series, these 4. These are pocket type multimeters with basic accuracy of 0.5%, which is standard today. They may have less function because of their form factor, but if they have a function, they master it. Look at the displays. You can't probably see it in the video. They are even backlit and they have bar graphs. What pocket size multimeter has bar graph? They also have auto hold, or you may know it as touch hold, and even adjustable low pass filter. But I don't think 4220 series will break sales records, so people rather buy cheaper pocket type, and then saved money can be invested in better main multimeter for your regular work. Then it's 4250 series, again for multimeters from this series. It's middle class of classic multimeters for everyday use in wide spectrum of applications. Dual display is very neat for examining AC voltages and currents, for example. And again, we got fully featured bar graph with update speed of 40 readings per second. Beautiful. Basic accuracy is 0.3%. It's nice to have, but actually it goes far beyond that. We will talk about it later. Unfortunately, the chassis allows only for 3 banana holes, so you can choose to have amps or milliamps, not both. That is quite unfortunate, so I chose the 4256 that has amps, as I consider 10 amperes to be more widely used than a few hundreds of milliamps range. We also have infrared optics, I can show you here. It's for USB communication, and they all have it from this series up. The adapter is sold separately alongside with CD with software. You can also connect external passive current clamp with adjustable conversion ratio. Of course, the multimeter also measures frequency on current ranges. Safety here is on a higher level, as we got 600 volts in Cat 4, so that means you can be running around 400/230 volts distribution room with this multimeter in hand, and you will be okay. Unfortunately, you shouldn't operate around 690/400 volts lines. The newest 4261, that is higher grade and of newer generation that allows for Bluetooth. I hope it will continue with newer models that have slightly different functions. 4261 is twice as accurate as 4250 series. The basic accuracy is 0.15%. We will of course also check that, and it supports high voltage probes. It also has this barrier. You won't see it, you will see it here, this barrier that happens to appear only in 3 brands of the multimeters in the world. 4280 is the high end, more like for laboratory than for general use, with beautiful accuracy, analog low pass filter. Only bad thing, it doesn't have bar graph. All Hioki multimeters withstand fall, or should withstand fall. I haven't tested that, of course, from 1 meter, and they have page 5, they have rubber sealing O-ring around the rotary selector. These leads, they are perfect. We will show them. Then page 7 talks about high ends being able to put DC and AC components apart and measure ripple, for example. The back of the catalog shows many different tips and probes, and even passive transformer clamps. It is convenient to have them for some people, as you have 2 in 1, of course. You don't need to carry 2 multimeters, and you don't need to buy 2 expensive multimeters. You just buy 1 regular DMM plus 1 quite cheap current clamp. There are also active current clamps even for DC currents, but Hioki seems not to offer them. These are all AC, unfortunately, and it is a shame, as with active clamp you can save the clamp position for some other functions, as active clamps provide voltage signal, usually like 1 mV per amp or so. You can also connect passive clamps on current range as long as it's shorted by internal fuse, and you can put protective anti-parallel diodes in the clamps, and you are pretty much good to go. There will be no problem connecting clamps to current range and just adjust the ratio on the multimeter, and boom, you can save this range for anything else. Hioki has such colorful boxes with info on them, which is nice. And here we have the entire line of 4250 series. The box contains 4256, of course. Then it's manual from Vox paper, and it also explains things like what true RMS is. There is operating precautions, is that sort of spam that must be included, but no one has ever found use to it other than to start a fire, of course. Package includes 4 AAA batteries. These are alkalines, That's nice of them, but hey, wouldn't it be better to ship Sanyo or Panasonic? Something made in Japan? The leads may look ordinary from far, but upon further inspection, they are actually quite beautiful. Cat 4 cover, well, everyone loses this cover anyway. I shall focus on this and lock it. Yeah, that's better. Tips are gilded, which I find perfect as gold doesn't tend to oxidize. These standard silver-like colored tips one usually gets with his multimeter are nickel plated, and nickel oxidizes, and sooner or later the contact resistance will drive you crazy, so you will keep sandpapering the tips. But gold doesn't oxidize. So good on you, Hioki from Japan. The gray body ends with nice stress relief that makes the radius bigger, so you don't crack your insulation or copper here. Insulation has nice matte finish, and it's some kind of maybe silicone rubber or something. Definitely better than classic PVC. There is also something like too soft insulation, and it's silicone UL3135. It's rated for 200 degrees Celsius, but these are definitely unsuitable for multimeter leads. Believe me, I own them. Now, the gauge of the wire is 18, that's like approximately 0.25 millimeters squared, and that's quite okay for 10 amps. The banana plug is of course fully insulated and also has insulating tip. The multimeter itself fits in hand quite okay, maybe it's a little on the thicker side. The outer blue rubber shell is removable, but you wouldn't need to do this unless you want to open the whole multimeter. Up here we got infrared, PC communication, and a little hook for magnetic strap, sold separately, just as the communication. Lead holders, well, I have personally never used them. Battery and fuse compartment can be accessed by unscrewing this SLPH2 bolt, I believe, that holds in the cover and goes to brass metal insert. Only one sort of batteries is worth to be put in such a Japanese meter, and it is genuine Panasonic Sanyo Eneloop Pro, also made in Japan. The only Japanese AAAs I have. Funny thing is that the plus contact is also gold plated. I may turn on the flashlight on my phone. It's also gold plated, so even just a tiny detail. Fuse is standard 10x38 HRC fuse rated for 11 amps, most probably the best you can get. From the other side of the leg is something that is little genius, and I am thinking, why isn't it a standard? It is short instructions on what button to press during startup to do what. We can activate or deactivate automatic power off or automatic backlight off, and it is permanent. Multimeter even remembers it after next turn on. Beeping off or show version is only applied for the actual session. I can only think about one slightly better solution than this, and it is, for example, what M-Probe has. It's this icon is automatic power switch off indication. You can turn that off during running by long pressing rel. Now the automatic power off is off, and it's during the multimeter running. It's slightly better solution than this, but this is definitely okay as it holds for the next time you start it. The DT4261 packaging is very similar. We also get the multimeter, where, surprise, the manual and the official regulations are also similar. 3 AA's are also included, and again, not made in Japan. That makes me so angry. I'm not gonna use them as they are not worth to be put in something that precious. And the leads, oh, the leads, they have perfected them in this newest series. Remember the caps that are doomed to be lost? Well, not here. Look, this is standard Cat 4, but then I can unlock it, pull and lock. Boom, Cat 3. Naked electrodes are great for extra low voltage work. or when testing electric parts, for example. For working on live wiring, bus bars, etc., it is safer to have them covered with only tips sticking out. Yow, they are sharp. Neatly done, Hioki engineers. And of course, they are gilded. The meter itself is similar to 4256, with exception of this being IP54 certified. The rain is gonna drop here, you say. Well, of course, but this multimeter also has drain. So you need to place gutter under the DMM, under this part, so the stream won't end up in your shoes. Or you can just put a drain bolt here. Here we can see something is hidden. Should this multimeter be lower end model and not have amps? Not at all. We were bamboozled by the protection mechanism that doesn't allow you to measure current in outlet, as we say. It prevents accidental switching to voltage range while still having leads in amp hole. Needless to say that the 30 milliohms between amps and Comm holes represents almost short circuit, so the explosion would be bad and make you angry about melting your brand new gilded leads with sophisticated cover. You don't want to melt or sublimate them. This cover actually uncovers amp hole only if you switch to the correct range, and as you can see, such mechanism was invented, I believe, by Gossen Metravat, and I also spent some time by their stand on the Ampere 2022 and had interesting dialogue with their representative, but they weren't that much into cooperation. Aside from Gossen Metravat and Hioki, there is third last brand to have such protected holes. It's Holtpeak. Being as Chinese as it's possible, this feature makes it interesting at least. Hioki has the mechanism of better quality, of course. Let's try to hit between ranges. It's difficult since Hioki has nicely clicking selector that helps you into each position. Here we are. Moment of, we call it scissor or shear in Czech language, when one valve is closing and second began to open. Such position is used to determine that opposite cylinder has compression and its valves can be adjusted. But let's keep up with multimeters and not engines. Let's get to the actual testing, and that's where my channel gets different from most of the other YouTube channels. I have begun working on this table like 2 months ago, and it is supposed to help me test every single important parameter review digital multimeter. Table is currently in version 1.2.4. The file is available for download in the video description, so if you have 2 monitors, I recommend pausing the video and opening the table on second monitor. Both DMMs have dual display with fully working bar graph. Dual display is nice to have, mostly for AC measurements. Bar graph is true here, as the update speed is 40 readings per second, or 40 fps for Hioki 4256 or 25 fps for 4261. I feel an urge to mention that Chinese bar graphs are sometimes useless, as they update alongside with the main value on the display, which gives you no advantage at all. These OK bar graphs have separate ADC, so they can be faster than the main integration ADC with high precision. Main value ends at 5999 and secondary at 4 nines. Both displays have refresh rate for main values as fast as 5 readings per second, rendering the multimeters more on the fast side. Classic update speed is around 2.5 to 3 readings per second. Backlit is comfortable to your eyes. Well, come on, stupid mobile phone. It appears a little cooler in the video, but believe me, these two are like 4000K white light approximately. It's my favorite color. It's natural white. Actually, human eye is most sensitive for green color. That's from our ancestors who hunted their prey in tall grass and forest. But I know only one green backlit multimeter, and it looks really strange, to be honest. So this 4000K approximately is the best. What is worst is blue. Human eye is least sensitive for blue, so having any text or symbol backlit with blue means more eye stress and more eye pain. Yet still, AliExpress is full of blue backlit displays. The backlight turns off itself automatically after 40 seconds, but you can turn that function off until you decide to turn it on again. Viewing angles, that's what makes such multimeters professional, because you can see them from any angle. No blind angles whatsoever. Both DMMs have range button, force range you want. Fortunately, they don't need it as they are very fast. 4261 even blinks actual range on display if you measure ohms. Nice attention to detail, as you don't have to focus on where is the dot and where is the unit and think about it. We got then classic max min functions, but it also has averaging function. It averages value with every reading. Bad thing is that it beeps every time the average value updates. It's annoying to have something constantly beeping, but nice function. Both multimeters also have hold button, which is like the most standard button out there. What isn't that standard is auto hold. You long press the button, and then after you measure something, the multimeter freezes the value automatically as soon as it gets stable. Now, for example, this 9V battery that is already discharged, it has locked, and now the value is frozen for me to read it, and then I can engage the auto hold one more time to wait to trigger when I perform the measurement. This is great for when you are out in the field and you are, for example, practicing yoga with multimeter leads in hands and your multimeter is not in line of sight during measurement. This can be somehow substituted using max function, but the max function detects more peaks than likes hold the value. Both selectors have excellent switching, and the arrest positions like to lock you in until you manage to put so strong force to make one complete click to the adjacent function. 4261 is a little softer when it comes to switching resistance, so it can be more easily operated with your thumb. If a guy from Hioki happens to watch this video, then please look at this unity selector. This flattened ending is made purposely for thumb, and it's rubberized. You may consider something like this in next gen DMMs. It's more comfortable. Here I have the app that was for the Hioki. Here we have general measurement. As we can see, the value on the display is visible here. Then I can go to data logging and set the interval for logging and set how long will I be data logging. I also have comparator. I can set the criteria of greater, lower and such. Then we have FFT, that's for later, and we have our data. That's what I have already measured in terms of testing. This is a pass-fail test. I set the threshold to 6 volts, and now anything above is fail and anything below is pass. Here we can see the list of the performed measurement, and I can also put any comments for any measurement. Then I have this data logging. I can of course use the cursors to look for the exact values, or I can show statistics. Now, what is this? Create report. Well, I have already created one report, and that report was from data logging. I can make it a little bigger. This is just test. So here we have date, instrument, measurement information, statistical information, nice chart, really nice, and table of the values. If a meter can do this alongside with software,
then it's definitely professional meter, and its usability is far beyond regular DMMs. What is also far beyond regular DMMs is the FFT. I will not use it now, but I will show you screenshots because there is no data available right now. Because I have nothing connected to it. Well, the multimeter is able to perform FFT, which is unusual. So unusual that I haven't seen this in any multimeters whatsoever. You would need a portable oscilloscope or spectrum analyzer or anything like this. The multimeter can tell you the THD of your network. For example, if you have frequency converters and such, they will make the THD bad, and for example compensation capacitors may then be exploding in your factory. With this instrument you can tell whether the THD is the source of the explosions or not. It can also perform FFT and the waveform function for currents, also with clamps on. So the usability of this multimeter is beyond any multimeters I have seen so far.
Regarding notifications, 4256 has notification LED. That's good because you have not only beep alert but also visual. Let me just turn off the lighting here. As you can see, the notification LED is a little on the slower side compared to the beeper. Now, how about notification for 4261? 4261 solves one problem, and it is that the LED is too small to notice sometimes. Well, the notification window for 4261 is somehow like 55 times 40 millimeters big. Yes, it's the entire display. Its backlight goes bloody red, so everyone within 100 meters range can see that you have continuity. Neat, really. We have already talked about chassis during unboxing, but let's move to the leg. There is definitely room to improve this. 4256 has the leg too flimsy. It doesn't hold position that strongly. It's true that most multimeters I have seen so far have bad legs, and some of them even totally useless. This leg is somewhere in the middle. UT61E Plus has the best leg in my opinion from what I have seen. However, 4256 still holds its place even during switching the rotary switch or during pressing buttons. That's quite okay. But this can't be said about 4261. This leg is near useless, and it is shame. Such a precious meter with such a low, below average leg. I haven't even pressed the button. See, I will try to press the backlight button. Yes? No, I won't be able to press it on the leg. I personally use all my multimeters on their legs to save some space on my desk. Banana sockets, they are perfect as they are of one piece of material and screwed with both two strong strips that are soldered to PCB. Now we have gotten to something more exact. Voltage measurement. Speed of it, it's beautiful. Let's see. Now let's test the 4261. And now with locked range. Speed of the measurement is beautiful. I might have seen faster DMMs, but they weren't as accurate though. Interesting is the bip once the multimeter switches ranges. I have never seen it. The multimeters also have smart voltage measurements where they automatically decide between AC or DC and to my surprise they are just as fast as on dedicated DC mode. 4256 has low Z under automatic mode, while 4261 has dedicated position for low Z. In low Z mode the impedance drops from 11 mega ohms to 1 mega ohm, so it loads the line a little, eating some inductive mass. A very useful function if you probe around at least some 10 meters long lines. Personally I would prefer 300 kilo ohms rather than 1 mega ohm, but it's still okay. Regarding DC millivolts, both multimeters have the most sensitive resolution down to 0.1 millivolts, so you cannot measure below 100 nanovolts. Now a little surprise. Filter. Low pass filter. Both DMMs have switchable low pass filter to, let's just use AC, off, 100 Hz and 500 Hz and off. When off, they are limited by the true RMS ADC, 4256 being able to measure up to 1.5 kHz to keep within specs, and 4261 up to 235 kHz. The low pass filter is great as it blocks higher frequencies that may be caused by frequency converters or like more switched mode power supplies on the line. Now the funny part. I checked for the accuracy on my 10 volts DC reference. Both of them said 10.00. These DMMs have more accurate ADC than what their display can show. They are also very far away from nominal 0.3 accuracy for DT4256 or 0.15 for DT4261. Considering that if they measured, for example, 10.005 internally, they would keep changing between 10.00 and 10.01. We can say then that the multimeter thinks it may be somewhere between 10.000 to 10.005, as both of them changed to 10.01 for a tiny little bit of the time, but they kept 10.00 almost all the remaining time. Such a trick is also done with analogs, where the gauge isn't accurate at all, so you also say that the hand is somewhere in, let's say, 1/3 between 12.5 and 12.6, so you say that it's like 12.53. Same trick can be applied to digitals, although don't tell anyone, as this isn't official way to do this. So considering my approximation, the real error would be around 0.0083%. That would make them fall into 0.01% accuracy. The 4256 is 30 times more accurate than what it claims to be. The display is the only limit here. If we had one more digit, the last one, we could get even better number. I would recommend putting more digits displays in their equipment. 5 is okay for such a multimeter, like for example 22,000 counts at least. Overvoltage warning is present in most today's multimeters, and Hiokis aren't from past. They beep and blink, and unfortunately they won't show the actual value. You shouldn't be doing this, but I used to measure, like for example 1.5 kilovolts with Chinese DT830 because it showed the value even if rated for 1000 max. Definitely a bad idea, since it was voltage on 136 microfarad capacitor and the stored energy has potential to kill. To measure up to 2 kilovolts you can buy Hioki high voltage probe that is compatible with 4261. Do not measure above 1 kilovolt with these multimeters. It blinks the backlight. Here you can see it. Both DMMs have only big ampere here, 10 amps to be exact. The best resolution is down to 0.1 milliamp for 4261 and 0.01 milliamp for 4256. Maximum current of 10 amps is a little unfortunate, as I consider having separate 20 amp alongside with separate milliamp/microamp ranges the best. These 10.00 milliamps to 10.00 amps are something between If it's the only option to have one current range, then okay. But again, two current ranges are far better. Their shunt resistor for current measurement has 10 milliohms, and the overall resistance between amp and Comm hole is around 30 milliohms, which is beautiful. Such a small resistance not only means that you won't affect anything by measuring it, but also the multimeter doesn't overheat, unlike these melting ananks, for example. Both DMMs measure frequency for current, and 4261 can perform our beloved FFT and any other functions within the app also for current. They have also adjustable low-pass filter for the currents too. My sample of 4256 is a little off calibration, I would say, as it had approximately minus 0.3 milliamp offset when there was no passing current, and I didn't know why. Both these meters are samples for demonstration purposes where people go around and play with it, so it may be caused by this. I measured error for 1 milliamp, and 4256 had error of 0.108% from range. 4261 had error of 0.38% from range. 0.38 is overall acceptable for generic measurement, as the borderline is somewhere around 0.5%, but being on range that doesn't cover all digits, it roughly covers 2 digits, it's always limiting your reading to increasing error from value. And that's the practical difference between error from range and error from value. While error from range may be just 0.38% and it's acceptable, the error from value is huge because you only use half of the display, and that's about the only higher currents being there. Let's go higher. Let's measure current these meters are suitable for. 9 amps, 90% of maximum current. Remember how I kept applying 90% of nominal current to my Unity, Omon and Anang and KVs for 1 minute? Why that? Because 90% of nominal current can heat up shunt resistor quite a lot and cause significant error. Anang was almost glowing hot and error was 5%. 5% error is guessed estimation, not measurement. Well, so I was applying 9 amps for 1 minute and the error climbed to 0.08% from range. Beautiful, really beautiful. 0.08% is definitely a measurement, and good one. If you overload the current range above 10 amps, meter makes sure you know you screwed, so you have the opportunity to save your HRC fuse from blowing, and these aren't cheap and you can't find them everywhere. Talking about overload, how about thermal overload? I tried applying 10 amperes for 10 minutes and nothing happened. Accuracy was still great. I could feel only small chassis heat up, but nothing more. My Unity actually can't handle even 10 amperes constantly. Now, when the fuse blows, how do you figure it out? One method is to perform continuity check on your ampere hole. You do this as shown. The fuse is good, but 4261 has the current hole covered. So how do you check the continuity of it? Well, Japanese guys are aware of that, so they implemented internal fuse check so the multimeter would tell you about blown fuse, which is very neat. Only few meters can do this. Continuity check or beeper is implemented very well, maybe even almost perfectly. Acoustic response is absolutely quick. It has no rising or fading time, just instant on or off. 4256, however, has a little slower visual response of that LED. But 4261 has the indication instant, just like the beeper. You can't see it, right? 4256 has 9 more decibels according to my decibel meter. Both multimeters need 30 ohms or lower resistance to beep, which is perfect. Unlike Fluke, with its up to 400 kilo ohms beeping piles of gooey sticky shit. Yes, we have 4 Flukes that beep at hundreds of kilo ohms. Awful. Hioki has more advantages to its implementation of beeper. You switch to the appropriate function and you can begin beeping instantly after rotating the selector. All my multimeters, all of them require you to press select button once or even twice to get to the beeper. So what do you need more often? To measure resistance or goddamn diodes? No, you need beeper. That's what you are here for 95% of cases. Finally someone who was actually using his brain when designing this. What both DMMs do not handle that well is diode test. 4256 has open circuit voltage of 345 volts, but it won't show more than 1.5 volts on the display. 4261 is similar, 1.9 volts out of it, but won't show more than 1.8. Why so? They are made for classic rectification diodes, maybe 2 in series, but hey, it's 2022 and people need to check their LED diodes. 4256 can even light up even white LED, but it shows over 1.5 volt instead of the actual value. Why degrade that? At least there is also one upgrade to compensate for it. They beep on the diode range if the diode is shorted. So, if your diode has been tortured by either high temperature or high current spike and it has damaged silicone, we say it has melted, but it's not actually molten, just the PN transition is broken and the PN transition is permanently conductive. Diodes usually fail this way. Other way they fail is their reverse blocking withstand voltage decreased, but one needs more sophisticated instruments for test. Capacity of the caps can also be measured, although I don't know why these DMMs still have to measure it, since you won't find faulty cap just by checking the capacity in like 90% of cases. You need bridge AC LCR meter to test caps, so the capacity measurement may be as useless as it is, still persists in most multimeters up to date. Unity, Ovon, Eineng, come on, it's time to stop. Hioki takes 7 seconds to measure 1000 microfarad capacitor. That is quite a horrible time, but again, if you are sane, you wouldn't use this function at all. If you want to go cheap, you can buy universal component tester. They are great for the price, and if you want to do serious cup business, and I don't mean Fallout game currency investment, but rather cup measurements, you are left with no choice but to buy LCR meter that shows ESR. Both multimeters can measure frequency for voltage or current up to 99.99 kHz. Needless to say that on these frequencies the voltage reading is quite off, of course. Unfortunately, these aren't able to perform PWM measurements. They won't measure duty cycle. It's a shame, as may I never have used it since I got some oscilloscopes, but many people would have use for that, for example around lighting or motor drivers. NCV, or non-contact voltage detection, can be performed with only 4256, and it only has 1 degree of that. Just 1 degree, that's like multimeters 10 years ago. Come on, remove it. No one will notice, since this isn't electric installation multimeter and it's halfway useless anyway, as it's implemented this way with only 1 degree. If you want to do some serious NCV stuff, you end up buying something smaller with more degrees or adjustable sensitivity. 1 degree NCV, it's like it's there just to be there, for more functions, but not to be used. However, if you have a clamp meter, you want it to have good NCV and maybe even light detection. Regarding power, we must think about this topic as it gets more important the more accurate and more sophisticated our multimeter gets, since all this increases power consumption. 9-volt blocks, they used to be pretty common, but they are trashy from their design. At least they can be easily shorted, so we will throw them out sooner. Engineers at Hioki know how bad 9 volts are, so they have their DMMs powered with classic double or triple A cells, as we have shown during opening. Hallowed are the Hioki, not Ori for you Stargate guys, and hallowed are those who walk in way of classic cells, or 18650. I have measured power consumption while measuring voltage and considering 1 amp hour for AAA and 2.5 amp hour for AA. 4256 can work for 164 hours of constant runtime, while 4261 gets to 245. These are nice numbers considering the accuracy, double display with quite high refresh rate, and bar graph with very fast refresh. They last even longer than my UT61E+. There is one thing that I have been wishing for and maybe even praying for, and I even wanted to sacrifice a goat for it, but I don't have to. This is the first multimeter brand that has battery indicator even on classic displays. 4 degrees of capacity, empty, and then 3 degrees more. Beautiful, beautiful. Finally someone, finally. I know these have been around in graphical display multimeters, I also own some, but not in the classic ones. Finally someone. And do you know what's even better? They are nickel metal hydride compatible. They may keep having 1 or 2 bars, so it doesn't indicate the full battery, but they turn off at only 1.0 volts per cell. So this one turns off at 4 volts and this one at 3 volts. Nickel metal hydrides are near empty at this voltage anyway, so good job designing the power part. Cause, you know, there are multimeters with high current drain that turn off at 1.2 volts per cell. Inconvenience, uneconomic, unecologic, just all bad. But Hioki knows that, and they are okay with these rechargeables. Only thing, you have 1 bar less. One more thing into power is automatic power off, usually called APO, but here it's APS. You can turn it off permanently until you decide to turn it on, as we said. Incoming APS is indicated by blinking values on display. That's nice, as it doesn't turn off just out of nowhere, like hold peak does. When the multimeter has turned off, it shows APS on the display and it draws circa 1/3 of power. What's really good is the fact that you can wake it up just by pressing any switch. It may be a little concern, but do you know how annoying it is to have to switch rotary, switch off, and then back to my function? And let me tell you something. This one, if it turns off, you can also turn it on with some buttons, any button press, but it begins holding. Yes, for real. Anything you press to wake it up, like max min, it will just trigger hold automatically. It will also trigger hold if you want to turn backlight on or off. Piece of slippery intestines product. Safety, one of the most important aspects. Well, both multimeters are very sturdy, quite heavy, and they no doubt meet Cat 4 rating for 600 volts. Interesting fact is that varistors are not present in these. Yes, we have PTCs, yes, we have high voltage resistant resistors, even 2 of them in series, but instead of varistor there is this glass gas discharge tube. To use GDT is actually smarter than you would think. Sure, it's more expensive, but at least from what I learned from my playing with arcs and varistors, then arc of ionized air, or any gas in general, is very effective in terms of limiting voltage. Just remember, how much does your voltage drop if you have a welding machine and strike the arc? You can be running literally 100 amps and the voltage around 20 volts maybe. I don't know, I mostly wear thin sheet metal plates on 15.5 volts, but I also use like 17 to 18 volts for thicker steel. So wasting excessive electric energy in plasma arc is actually very effective. Barristors can explode and then they no longer protect you. Plasma arc will just be there until you remove current or there is no material left to serve as electrode. Very safe, I would say. The conclusion is gonna be richer a little, since such a long video filled to the top with information must have loaded your brain heavily. Mine too, actually. Making this video took me more than 2 weeks of full afternoon work of preparations. Just preparations, not recording, right? But these instruments, they deserve it. The build and overall quality is excellent. God damn it, we even have gilded battery contacts. 4261 even has IP54 and wrong hole protection. What I don't like is lag. Both multimeters deserve better lags and the 4261 definitely does. This is just bad. Selector could have 2 off positions, or even better, the multimeter could have separate power button, but there is problem with having a multimeter on function even when off, because you can blow it. Well, I still like the power button more, but it's bad idea to implement it in industrial multimeter anyway, because of the blowing. Then there are currents. You have to choose between smaller or higher currents for 4250 series. The only Hioki to accommodate both is the highest end model 4282 for like 500 euros. If you choose a higher current version, you have maximum of 10 amps. I have always preferred 20 amp models over 10 amp ones. Well, apart from mention, these multimeters have everything else implemented just as it should be. Continuity test. Absolutely perfect. Fast raising and fading time, fast response, dual indication with LED or red display, and it requires less than 30 ohms. Moreover, it is the first function in that respective selector position. You don't have to keep pressing function button or select button. Yes, you just go there and boom, you can beep. Speed of measurement is also beautiful. Of course, it's faster than analog voltmeter, but even compared to digitals, it's above average. What's also nice is fact that selecting some of the smart AC/DC modes doesn't affect the measuring speed. Now displays, these are top of the line, really. Perfect viewing angles, cozy, warmer, neutral, white backlight, good for your eyes. Oh, the display is dual and has 5 readings per second. Nice. They also got full featured bar graph, which is not visible now, but now it's visible, yes. And even something I've been waiting for such a long time. Battery capacity indicator. Neat. Moreover, it can be powered with rechargeable cells, double or AAA. Not these ugly 9 volts. Hold and auto hold. Super. Max, min, average. Good to have. Make 'em handy. Settable low pass filter. Oh man, this is common only in twice as high price range. Quite fine. Quick guide under the leg. I hope you can see it. You probably won't. Anyway, the leg tells you what button to press during startup to toggle what function on and off. We've talked about it. Someone was clearly thinking here. And the accuracy of approximately 0.01% on DCV range, that goes beyond resolution of the display. Current measurement may have downsides, but here are bright sides. HRC fuse with high arc breaking capacity comes handy to save your multimeter from explosion. Perfectly massive input terminals and resistance of just 30 milliohms hole to hole. When on ampere range, oh man, 30 milliohms is common for 20 amp multimeters, not 10 amps. About the communication, well, I haven't unfortunately tested the PC software, but the Bluetooth communication, are you kidding me? it adds so much of usefulness to this small device. So many functions, FFT and basic scope alongside with THD. This isn't common at all. You can literally check THD of a factory network and tell that they need some LC filtering. And you can tell it just with your multimeter in hand and your phone in second hand. You would otherwise have to bring portable oscilloscope or analyzer or anything like that. And those are like 20 times more expensive at least. Moreover, if this still isn't enough industrial for you, well, how about the dedicated clamp function on both of them actually? Well, of course, practically any multimeter can handle current clamp, active or passive, but you would have to do the calculations by yourself. Here you can set the ratio and you have your hundreds or thousands amp or anything like this on your display. You can just adjust the ratio. So it's just multimeters for wide variety of jobs. You can do industrial stuff like keep dropping it from 1 meter while measuring voltage after frequency drive with your low pass filter set to let's say 100 Hz, or you can do some lab stuff with your multimeter on your table, sitting by it in your white overall, having your DMM connected to your PC and data logging, and of course you will be data logging some values with precision of 0.01%. Now, how about the price? Well, here in Czech Republic the prices go like 186 euros or $200 for the DT4256. DT4261 costs 271 euros or 291 US dollars. If you want Bluetooth adapter, then buying it in set with this multimeter is cheaper. But if you go the more expensive variant and buy it separately, then the Bluetooth adapter itself costs 100 euros or $108. All prices of course include 21% tax. For this price you get 3 years warranty to the machine and 1 year warranty for the precision. Well, the prices, they are above 100. They aren't generally that low. But considering all the functions and quality, it actually becomes cheap. Now really, if you wanted to get something similar from direct competitor, like Fluke, let's say, you would have to pay twice the money, at least, maybe. For Gossen Metrawatt, it's like 3 or 4 times more. And Probe is quite function poor to compete with Hioki and Shavin-Arnoux, or how do you pronounce that? Shavin-Arnoux? I don't know. Well, the yellow one. Shavin costs same as Fluke, but it's useless piece of garbage, and I will tell you why. They all have blue backlight. French engineers are well known for the ability to seriously fuck up something absolutely basic, as we know from cars, for example. And I personally also know. Who would possibly say, "Messieurs, we shall use the worst color that exists, to the human eye is least sensitive so let's use blue." There is only one brand that could possibly compete with Hioki, and it is Unity brand. Unity offers something with comparable functionality for the same price, which is great. But from my experience with their buggy software, well, don't even think about using it professionally. Overall, Unity is good brand, really. Good quality for China, but definitely less industry grade than Hioki. That is even made in Japan, this is made in China. So it happens that these multimeters have practically no competitor, but if you don't want anything that industrial, you may go for Unity. But still, functionality plus dependability for money ratio is unbeaten. So the end, I thank the Teste company, that is distributor for Czech Republic and Slovakia, for lending me these nice, precious multimeters. They are practically unknown in Europe, and it's shame because they deserve to be sold between professional clients. Links to these multimeters on both distributor and official Hioki page are in the description below. Before leaving this YouTube page, please write what you think about them multimeters in comments, cause I almost adore them. That's all for this video. I'm gonna wipe my tears about because I have to return them back as they are borrowed, and see you in another video. Goodbye.